Good morning everyone. Today we are discussing regarding problems on first order circuit. In this question they have given a square wave input and a resistor, a diode, a capacitor is connected in series. So what they asked is Vs is 10 volts, square wave with the time period of 4 milliseconds. 4 milliseconds means total time period is 4 milliseconds. Up to here it is 4 milliseconds. So t by 2 means 2 milliseconds. So first half wave is 2 milliseconds, next half wave is 2 milliseconds. So diode is connected across source and capacitor. So negative half will be not allowed through this diode. Only positive half will be conducting through this diode. They have given resistance value 500 ohms and capacitor value they given 10 microfarads. Capacitor is initially uncharged, so Vc of 0 is 0 volts. Diode is assumed to be ideal. There is no voltage drop across this diode. The voltage across the capacitor, they are asking capacitor voltage at 3 milliseconds. What is the voltage drop? Voltage at 3 milliseconds. In the input waveform, if you see this, this is 4 up to 4 is a full cycle. They are asking the voltage at 3 milliseconds. That means it is a negative pulse. At the time of negative pulse, the diode will not conduct. So input may not be applied to the capacitor. Whatever the charge up to t by 2 time, the charge will be remaining up to t, and again it will be charging after t plus capital T. So at t is equal to t by 2, what is the voltage obtained will be remaining at t is equal to 3 milliseconds. So voltage at 2 milliseconds is equal to capacitor voltage at 3 milliseconds. Now so we will be obtaining the Vc at 2 milliseconds. We know voltage across this capacitor V of t is equal to standard equation final voltage plus initial minus final voltage into e power minus 1 by RC into t. This is the standard equation. From this 1 by RC value is 5 into 10 to the 500 into 10 microfarads. That means it will be equals to 200. And we need to find the final value, final voltage. Final voltage, as if you apply KVL here, Vs is equal to I times of R plus Vc. We know at t tends to infinity, capacitor current is 0. IC, capacitor current is 0. So IC is equal to I of t. So Vc is equal to 0 times of R plus Vc. From this equation, in source voltage is equal to capacitor voltage. At steady state, source voltage is equals to capacitor voltage. Source voltage peak value is 10 plus initial voltage they given is 0 minus final voltage is 10. The applied voltage they given is 10 volts. So we have taken this 10 into e power the 1 by RC value is 200 minus 200 into T. So we are now finding it VC at 2 milliseconds, that is 10 into 1 minus e power 2 into 200, that is minus 0.4. Sorry, it is the value will be 3.29 amps. Here at VC at 3 millisecond will be 3.29 amps. This is a direct question. For circuit magnitude of loop current, they are asking what is the loop current in amperes at 3 decimal places at 0.5 second after closing the switch. They are asking at 0.5 second what is the current at 0.5 place. We know standard formula I of t will be equal to final current plus initial minus final into e power minus r by L into t. This is the standard formula. If you put all the values, we will get the answer. R by L. Resistance value, total resistance value will be, looking from this inductor, this source RTH, we need to find RTH. Looking from the inductor, we need RTH. So voltage source is short circuited, and from the inductor place we need to find the RTH value looking from here. So there is 1 ohm resistor, 1 ohm resistor. So total RTH value is 2 by 1. The R by L value is 2. Now finding the final current. To find final current, then at t tends to infinity, the inductor work as short circuit. So the total current flowing through this will be I is equal to, total voltage is 1, total resistance are 2, that means 0.5 amps. This is the final current. Initial current I of 0 is equal to 0 amps. Therefore we got all the values. Then we will place in this equation. I of t is equal to 0.5 plus 0 minus 0.5 into e power minus 2t. I of t is equal to 0.5 into 1 minus e power minus 2t. At I of 0, they asked 0.5 second. I of 0.5 is equal to 0.5 into 1 minus e power minus 2 into 0.5. The answer will be 0.316 amps. In this question, S1 was closed, S1 is closed and S2 is opened for very long time at t minus that means before switching operation, this is closed and this is opened. Next, at a t tends to 0, S1 is opened and S2 is closed. They are asking voltage across the capacitor. Voltage across the capacitor formula will be final voltage plus initial voltage minus final into e power minus 1 by RC into T. This is the standard formula. Now we need to find first initial voltage. Initial voltage at Vc of 0. In this state, S2 is initial before switching, S2 is opened. That means I will redraw the circuit. S2 is opened. One volt, 10 microfarads and 2 ohms. Directly 1 ohm is applied across this resistor. This resistor and capacitor are parallel, so voltage drop across this resistor will be same as voltage drop across the capacitor also. So Vc of 0 is 1 volt, as is 1 volt is directly applying across this 2 and capacitor also. Now final voltage. Final voltage, we will redraw the circuit. This is closed and S1 is opened. Ten microfarads, 2 ohms and 1 ohm with 3 volts. So voltage across this resistor will be same as voltage across this capacitor. So Vc of final means infinity is equal to total voltage is 3 into I am applying voltage division rule, so that the voltage across this 2 ohms will be obtained. Same resistor by sum of resistances. 3 cancel, 2 volts is the answer. So putting in the solution, third step, Vc of t is equal to final value is 2 plus initial value is 1 minus 2 is equal to e power minus 1 by R value is we will find it out. This is the expression. From this RC and T, if you place means we will get the solution. To get we will find RTH value at t greater than 0. So at t greater than 0, the circuit is final voltage. This is the circuit at t greater than 0. So in this circuit, we will short circuit this voltage and we will be finding RTH across this capacitor. So now from this the RTH value will be, these two are in parallel, so 2 by sum of the resistances 3. This is the RTH value. So C value, and C value is 10 microseconds. We will place in this equation. 1 by RC will be 1 by 2 by 3 into 10 microfarads. That means 3 by 2, 10 multiplied here 20. This micro goes up, then it will be 10 to the power of 6. So Vc of t is equal to 2 plus 1 minus 2 is minus 1 into e power 3 by 20 into 10 to the power of 6 into t at Vc of 0.5. They asked at 5 microseconds. 5 microseconds. 5 micro is equal to 2 minus of e power minus 3 by 20 into 10 to the power of 6 into 5 into 10 to the power of minus 6. This 2 gets cancelled out. 5 ones, 5 fours. So 2 into minus e power minus 3 by 4. The value will be, if you calculate this value, we will get the solution. The answer is 1.5276. In this question, in the circuit, the voltage Vin of t is given by Vin of t is equal to 0 for t less than 0, 15 volts for t greater than 0. That means initial voltage and currents applied on this circuit is 0, where t is in seconds, reach 2 amperes is, that means at which the current I in the circuit will reach the 2 amperes. They are asking if the current I here to reach the 2 amperes, what is the time taken in seconds. So first we need to find the total current here, and this total current is dividing 1 Henry and 2 Henry here, and we will find this I current. Then we will be finding the time taken to reach 2 amperes in this inductor. Now initial condition I of 0 is 0, as there is no input, the current also 0. At t tends to infinity, the current across this circuit will be, let find I of t through the standard equation V by R 1 minus e power minus R by L into t. Voltage applied at final stage is 15 volts. 15 by 1 minus e power minus 1 by L is, the L will be the equivalent of this, as we are finding the total current here. L equivalent will be, this is equivalent as same resistor, we can apply like the 2 into 1 by 2 plus 1, 3, that is 2 divided by 3 into t. I of t will be 15 times of 1 minus e power minus 3 by 2 into t. Therefore the current, we need the current, let we call this as I1 and I1. We need I current. So I current will be, the principle of current division in inductor and resistor will be same. So we can take current division rule here directly. We need to obtain the current here. To obtain this current here, we need current division rule. Total current is I1 of t into opposite inductor by sum of inductors. Total, we need the I value, so 1 by 3 of I1 expression we have here, 15 into 1 minus e power minus 3 by 2 into t, 5 times. So I is 5 into 1 minus e power minus 3 by 2 into t. This is the current at 2 Henry. Now we need at 2 amps. Then we will equal I is equal to 2 is equal to 5, 1 minus e power minus 3 by 2 into t. this goes here 2 by 5 and 1 minus e power minus 3 by 2 into t. Then e power minus 3 by 2 t equals to 1 minus 2 by 5. Then putting natural logarithm, then e exponential will be taken or cancelled, and 1 minus 2 by 5, and t will be 2 by 3 ln of 1 minus 2 by 5. The time in seconds will be 0.34 seconds. As we have minus here, the value will be negative of negative, then it will overall value will be positive. The time to reach the 2 amperes in this 2 Henry will be 0.34 seconds. In this question, the switch in the circuit shown in the figure was open for very long time. It is open for very long time. At a t0 minus, the switch is open, and it is closed at t is equal to 0, and it is closed at t is equal to 0. The current I of t in amps at 0.5 seconds. They are asking to find the current at 0.5 second. Current equation is final plus initial current minus final current into e power minus r by l into t. Now we need to find the initial current. Initially the switch is opened, so I am redrawing the circuit. And as the circuit is open, 2.5 Henry, the inductor will be short circuited. At t minus infinity, it will be short circuited. As the same resistance, the current flowing through this inductor, let it is say IL. IL value is 10 into they both are same resistances, or we can apply current division rule. 5 opposite resistance is 5 by total resistance is 10. Then 5 ones, 5 twos. IL will be 5 amps. This is the initial current, IL of 0. Then the final current. Final current is we will read of the circuit. It is short circuited as the switch is closed at t equal to 0. This is short circuited. At t tends to infinity, the inductor is short circuited 5 ohms and 10 amps. As there is a short circuit path, the current will not flow in the parallel branch across short circuited path. Then IL of infinity will be 0. So we will place in the standard equation I of t is equal to final value is 0 plus initial value is 5 minus final value into e power minus 1 by r into t. We need to find the r value at t greater than 0. At t greater than 0, finding the I value. Look, current sources are open circuited, and at t greater than 0 it's a short circuit, and we need to look from this path RTH. If you look from this path, there is only 5 ohm resistor and other is a short circuit path. So RTH value will be 5 ohms. And L value is only one inductor, so it is 0.5 Henry. we can write in this I of t is equal to 5 times of e power minus 5 by 2.5 into t. Now this is the current across the inductor, but they are asking the current at short circuit path, that switched path. So we will draw the circuit. At the time of switching, at t is equal to 0 plus the time, the current is, there is a short circuit across this path. So this current 10 amps will be directly flowing through this, and at t is equal to 0 plus, this inductor is also charged with the current IL. This is IL. So that value is 5 into e power minus 5 by 2.5 into t. So these both will be in flowing in the same but opposite direction. So the total current I of t will be 10 minus IL of t. This is an inductor current. No need to confuse. So 10 minus 5 into e power minus 5 by 2.5 into t. We need current at 0.5 second. Then 10 minus 5 into e power minus 5 by 2.5 into 5. The value will be 9.32 amps.